Hello and welcome to another exam paper walkthrough. Today I'm going to be carrying on with my GCSE maths series, and this is an AQA predicted topic paper. This is a paper that I am calling the paper 2/3F very likely paper. Now, attached to the description to this video, you'll find a link to a Google Drive where you can download a copy of the paper. If you've not already got a copy, I would strongly recommend you do that now, and either do it before watching the video or do it alongside the video just to get the most out of it and maximize your revision. I'd also recommend a bit of music on in the background. I quite enjoy doing maths papers with a bit of music on. It just makes the time go a bit smoother, shall we say. This is preparation for the June 25 series, and the topic list that I've used to produce this very likely paper has been produced from first class maths revision material. They've done it in terms of stars. I've then converted them into papers. If you've not already checked out First Class Maths website, then please, I would strongly recommend you do. You can type that into a search bar and look at their material. They've got some fantastic resources there. If you find this video useful, please do subscribe and you'll get any of the notifications as soon as other material is released. Before I get into the paper, I'll just describe what I actually mean by very likely. So this is First Class Maths revision list. They've done it as a 5-star, 4-star, 3-star, all the way down. But I've just focused on the 5-star and 4-star, and I've produced what I'm calling a very likely paper. And I've used the 3-star to produce a good chance paper. So that's already been released. I'd put a bit of time revising that as well, if you have the chance. Right, let's get into the paper. Okay, right. So question 1, match each expression on the left to the simplified expression on the right. Okay, so these two are going to add to make 7a. So we're looking for 7a. There we go. Those two match. These two are going to become 9a squared. So that's going to match to that one. This one is going to become 18a. So that would match to that one. And then finally, divided by 4, that would become 3a. So that one would match to that. Question 2. Which unit is most suitable for measuring the length of a tennis court? Circle your correct answer. If we're thinking about a tennis court, we're going to be going meters. Question 3. Pens cost 20 pence each. Rulers cost 60 pence each. Saj buys some pens and some rulers. He buys 8 rulers. The total cost is £10. How many pens does he buy? Okay, so if each pen costs 20 pence, I'm going to convert I'll actually convert this one into pence. Although we could have converted them into pounds, but we'll stick with that. Right, so we've got, if I call x the number of pens, we've got 20x plus 8 rulers, so that would be 8 times 60, and that's going to be equal to 1,000. So that means that 20x plus 8 times by 6 is going to give us 48, 480, and that's equal to 10,000. Sorry, 1,000. So if I minus 480 from both sides, I would get 20x is going to be equal to 520. And then if I divide both sides by 20 or divide both sides by 2, we'd get x is equal to 26. Question 4. Write down the ratio. So R to W is 1 to 4. Write down the ratio of R squared to W squared. So that's going to become 1 to 4 squared, which is going to be 16. Question 5. A fair ordinary dice is thrown once. Circle the probability of getting a 2 or a 3. 2 or a 3. There are 2 options out of 6, so we're going 2 over 6. Not over the moon about that, because that would be 1/3, which was what I was looking for initially. But 2 out of 6 is this equivalent. Right, question 6. How many minutes are there in 2 hours and a quarter? 2.25 hours. So we're going to do 2 times by, well, actually, to be fair, we can literally just do 60 times by 2.25. That would probably be the most straightforward. We'll bring our calculator in here just because I think it's a useful skill to just show you entering a mixed fraction. So if we do 60 times by, and then we want to press shift, and then that button there, that gives us the option of putting in a mixed fraction, so 2.25. So 135. And that's the first option. Question 7. What is 3/2 as a decimal? So that's going to be 1.5. Again, if you're unsure, you can type that in. Question 8. Which of these numbers is 3 less than a square number? 3 less than a square number. So what I'm going to do is I'm going to add 3 to all of them. Because that'll give us, there we go. We'll carry on though. So that's 3 less than a square number. Question 9. Ali revises each day for 5 days. On each of the first 4 days, he revises from 8 p.m. till 5 p.m. till 8 p.m. On the 5th day, he starts revising at 1 p.m. He finishes when he has revised for a total of 18 hours for the 5 days. What time does he finish on the 5th day? Okay, so 8 p.m. to 5 p.m. to 8 p.m. is 3 hours. So we want to do 18 minus 4 lots of 3, which is going to be 18 minus 12, which is going to be 6 hours. So that's the time that he wants to revise for. So if he starts at 1 p.m., so 1 p.m. plus 6 hours is going to give us 7 p.m. Right, question 10. Sophia is revising for maths. She tries to work out 3 times by 4 plus 2. Here is her working. 4 times 3 plus 2 is equal to 12 plus 3 is equal to 15. What mistake has she made? So she should do the brackets first. So she should evaluate the brackets first. And then I'll show what she should have done. So 3 times by 4 plus 2 is equal to 3 times by 4 plus 2 is 6, which is 18. Right, question 11. The table shows the number of messages Sam received each day for 5 days. So we've got our days and emails and text messages. Sam draws a compositive bar chart to represent the data. He has drawn the bar for Monday. Complete the bar chart. Okay. So Tuesday we want 8 emails. Let's just check emails is first. So 8 emails. I'm going to put in all the emails first of all. Wednesday is 10. Thursday is 6. Friday is 12. Right, I'll add a touch of shade in here. And just to make things a bit easier, I'm going to add the totals together here. It saves me adding 5 on top each time, provided I've done it right. Right, so I want to go up to 17, which is halfway. Oh, sorry. I've already got 17, so we agree with that. We want to go 14. We want to go 13. We want to go 12. And then finally 16. So there we go. Right, part B. In total, what fraction of the messages were emails? Give your answer in simplest form. So what fraction of the messages, so we want the total number of messages, were emails. So we need the total for messages and total for emails. So I want to add, I want to find this total, and I want to find this total. So, I mean, let's 20, 30, 40. I'll make that 48, but we'll double check that. And I make adding in pairs. So that pair would add up to 30. That pair would add up to 30. So 60, 72. Let's just double check both those figures though. 12 plus 8 plus 10 plus 6 plus 12 does add up to 48, and 17 plus 14 plus 13 plus 12 plus 16 does add up to 72. So we want, I forgot what my top number was, 48 out of 72, and that will cancel down quite a lot. I think 12 will go into them both. So let's go 48 over my last answer, gives me 2/3. Right, question 12. Circle the fraction that is equal to 1 over 12. Let's just see. 0.12 equals, there we go, it gives us as a fraction. It's nice and quick using my calculator. But if we went on a calculator paper, we could say it's 12 out of 100, and both of those can cancel down by 4. Which is longer, 3/4 of a day or 1,000 minutes? Okay, so 3/4 of a day, what are we going to be working in? It doesn't really matter. I'm going to convert this one into minutes. I was going to convert them both, but we won't bother. So 3/4 of a day is going to be 3 times by 24, and then there are 60 minutes in an hour, so that will give us our answer. So 3/4 times by 24 times by 60. So that's going to be 1,080 minutes. So which one is longer? 3/4 of a day. Okay, question 14. Use 1 stone is equal to 2.2 pounds and 1 kilogram is equal to 2.2 pounds. 1 stone is equal to 14 pounds to change 70 kilograms into stone. Right, okay, so I'm going to start by converting kilograms into pounds. Well, no, I'm going to say I need to do 70 times by 2.2 to convert that into stone. And then I need to divide to convert that into pounds. And then my conversion here would be divide, so then I need to divide by 14. I can treat it just like that. I don't need to go into any more detail really. So 70 times by 2.2 divided by 14. So that's going to be 11 stone. So 11. Question 15. Write down all the factors of 45. So for this, I'm going to just do factor pairs to start with. So 1 and 45 multiply together to make 45. 3 and 15 multiply together to make 45. 5 and 9 multiply together to make 45. So we're looking at 1, 3, 5, 9, 15, and 45. Right, question 16. Put these numbers in order starting with the smallest. So the easiest way to do this is to convert them all into decimal. This one's already has a decimal. This one we can do as 0.7. This one we should be fairly familiar with, 0.75. And then this one is less familiar. So if we do 41 divided by 40, and then as a decimal, that's going to be 0.775. Then we order them, starting with the smallest, which started out as 7/10. Our next smallest one is the only one that started as a decimal. Our next smallest one then is 3/4. And then finally 31/40 as our largest. Question 17. Which two numbers when added together make a cubed number? So we'll add them together. So 1 plus 8 is 9. 2 plus 4 is 6. 9 plus 18 is 27, which I know is a cube number. And then 8 plus 64 is going to be 72. So that's our cubed. Question 18, simplify fully. So collecting like terms, so we can collect our x's. I always like to underline and include the operator in front. So 2x plus 8x is 10x. Then we'll circle our next, including the operators. So plus 9 minus 5 is going to be plus 4y. And then our numbers, we've just got plus 1 minus 7, which would be minus 6. Right, question 19. Circle the expression that is equivalent to 0.5a squared. So 0.5a squared is the same as a half a squared, so that would be that one, a squared over 2. Question 20. A reel holds 9.5 meters of ribbon. 2 pieces of ribbon are cut from the reel. Each piece is 20 centimeters long. What length of ribbon is left on the reel? So 20 centimeters is going to be 0.2 of a meter. So I want to do 9.5 minus 2 lots of 0.2. So that's going to be 9.5 minus 0.4, which would be 9.1. 9.1, and then my unit there is meters. And of course, 910 centimeters would be absolutely fine as well. Right, question 21. A company uses this formula to work out the cost of a taxi ride. A is equal to 4 plus 1.8 m plus b. A £4 is a fixed charge. M is the number of miles travelled. B is a charge for booking online. Claire books a taxi online and travels 8 miles. She pays £20 altogether. How much is the charge for booking online? Right. Okay, so we're saying then that she pays £20 altogether is equal to 4 plus 1.8 times 8 plus b. Right. So what I want to do is I'll use my calculator to do 4 plus 1.8 times 8. So that is £18.40 or 18.4 plus b. Then if I minus 18.4 from both sides, that will give me 1.6 is equal to b. So the booking fee should be £1.60. Right, part B. A different company has a fixed charge of £3, charges £1.90 per mile, and has no charge for booking online. Write a formula for C for the cost C of a taxi ride with this company. So that's going to be C is equal to 3 plus 1.9, and what letter were we using for miles? Was it M? It was M. Right, question 22. The probability that A is the outcome of an experiment. The probability that A is the outcome of an experiment is 0.2. Circle the probability that A is not the outcome. So we want to do 1 minus 0.2, which will give us 0.8. So we're going for that one. Question 23. Match each sequence to its description. Okay, right. So if we look at this one, this is going up by 1, 2, 3, 4. No, not 4. This is doubling each time. So 1, 2, 4. So this is a geometric sequence. 1, 2, 3, 4, 5, 6 is an arithmetic sequence going up by 1 each time. 1, 3, 6, 13, 4, 15, 21. Those are the triangle numbers. 1, 4, 9, 16. Those are the square numbers. 1, and those are the cube numbers. So that's going to be my matches. Right, question 24. The x value of the tables make a linear sequence. The y value in the table makes a different linear sequence. Complete the table. Okay, so if we look at the x's first of all, 0, 2, 4, 6, 8, that must be 10. And then if we look at these are going up by 4s, so that must be 15. Draw a straight line passing through the point. So this is this, it is the same, yeah. So 0, 3 would be that point there. 2, 7 would be that point there. And then 4, 11 would be that point there. So I just need to join those up with a straight line. And I'm notoriously bad with straight lines on here. Okay, that's not too bad. Right, use your graph to work out the value of y when x is equal to 3. So x is equal to 3. We go up to our line and then we read off. So we're looking at 9. Right, question 25. Jess saves 2p, 5p, 10p coins. She has 45 10p coins, 8 times as many 2p coins as there are 10p coins. £17.70 in total. Work out the total value of 2p coins to the total value of 5p coins, given your answer in its simplest form. Okay, so we've got 2p, 5p, 10p coins. Right, if we look at the numbers first of all, and then we'll do the values in a second. So we know that there are 45 10p coins. We know there are 8 times as many 2p coins as there are 10p coins. 8 times as many. So if we do 45 times by 8. So 45 times by 8. So we know that there are 362p coins. And we know that there are £17.70 in total. Right, so that's the number. We can't do the other number just yet. So we'll work backwards from that. So the value. And we'll go for the value in pounds. So £2.60 is going to be, sorry, 362 pence coins is going to be 720 or £7.20. 45 10p coins is going to be a value of £4.50. So we've got our two values that we can use to work the value of the 5p coins out. So if we do £17.70 minus those two known values, £7.20 plus £4.50. That's going to give us the value of the 5p coins, which technically speaking is all we need to work out. Right, £17.70 minus 7.2 plus 4.5. So we've got £6 worth of 5 pence coins. So that's going to be 7.2 to 6. Now I want, that's not a fraction in its simplest form, realistically, give your answer in its simplest form. So that's not in its simplest form, mainly because we've got decimal here. So we could say that that's the same as 72 to 60. And then both those numbers will cancel down by 12. 12s will go into that 6 times, and 12s will go into that 5 times. So we're looking at 6 to 5. Right, question 26. The rectangle and the triangle have the same area. Work out the length of the rectangle. So if they've got the same area, we'll jump straight to saying that the area of this would be, if you call that x, 7.5x. And then the area of this is going to be equal to a half of 16 times 12. So I'm going to go 7.5x is going to be equal to 8 times 12, which would give us 96, I believe. But let's do that right from the beginning. 7.5 times 16 times 12 gives us 96. So x is going to be equal to 96 divided by 7.5. That's going to give us 12.8. Right, question 27. M is equal to PR. P is halved and R is multiplied by 3. What happens to M? So if we think that M is equal to P, I'm going to leave a deliberate space here, times by R. So P is halved, so we're timesing that value by a half. And R is multiplied by 3. Right, so if we bring that together, that's going to become 3 over 2. So times by 3 over 2. Right, question 28. Harry, Luna and Ron each have an amount of money. Harry has £72. Harry's amount to Luna's amount is 6 to 5. Ron's amount is 1.5 times Harry's amount. Show that in total they have less than £250. Okay, right, so our 3 people, H, L and R. We know that Harry has £72. We know that Harry to Luna's amount is 6 to 5. So we're putting these in as different parts. And we know that Ron's amount is 1.5 times Harry's amount. So we can actually say that 72 times by 1.5 is going to be equal to. So 72 times by 1.5 gives us 108. So Ron's going to have 108 pounds, and then we can work out Luna's amount by taking Harry's amount, dividing it by 6, and then times him by 5. So 72 divided by 6 times by 5 is going to give us 72 divided by 6 times by 5, 60. So that's their totals. We now need to add them up. So I should have put 72 there. So final step then, 72 plus 60 plus 108. 108 properly, 108. So they have a total of, we've already got 60 plus 72 plus 108 gives us 240. So that's their total of money, which is less than 250, which is less than 250. There we go. Right, question 29. Des delivers takeaways to houses A, B, and C. Scale of 1 centimetre to 3 miles. And then we've got our distances. A, B, C, T is the takeaway. Des drives from T to A, from T to A and back, and from T to B to C, then C to D, C to T. Des is paid 40 pence for each mile he drives and £1.35 for each house he drives to. How much is Des paid in total for this work? Okay, so he's going to drive from there to there. So I'm going to work this in terms of centimeters to start with. So let's say T to A to T is equal to 2 lots of 0.6. which is going to be 1.2. And then we'll do the circular route. We'll do it here, just so I've got enough room. T to B to C to T is going to be 1.3 plus 0.8 plus 1.7. Those are going to add up to 3, so that's going to be 3.8. We'll double check that though. 1.3 plus 0.8 plus 1.7, which is, perhaps something wrong there. I have, yeah, decimal point there. 1.3 plus 0.8 plus 1.7. 3.8, yeah. Right, so in total, he's driven, no, in centimeters, he's driven 5 centimeters. 5 centimeter total. And he's made, for each house he delivers to. So he's stopped at 1, 2, 3 houses. 3 houses. Right, so we need to convert our centimeters into miles, so that there's 1 centimeter is 3 miles. So he's, I've gone too far there. So if he's done 5 centimeters, 5 times by 3 times by the price that he gets paid for driving. I'm going to go in pence, times by 0.4 plus 3 lots of £1.35. So right, so 5 times by 3 times by 0.4 plus 3 times by 1.35. I've not made that a very good 5. I nearly typed that as a 3. So that should be his total, £10 and 5 pence. So £10 and 5 pence. Right, question 30. The sketch shows the line y is equal to x, line A, which is vertical, line B, which is horizontal. Point 3, 5 is on both line A and B. Write down the coordinates of P and Q. Okay, so we will start here. This has to be 3, 0. And then this point, because this coordinate here, 3, 5, is 3 here, 5 here. And point Q must be 5, 5. Because the y coordinate must be 5 because we're told it here. And then if y is equal to x, it must be 5, 5. Right, question 31. Here's a formula to convert degrees Celsius to Fahrenheit. F is equal to 1.5 C plus 32. F is the number of degrees Fahrenheit. C is the number of degrees Celsius. Show that minus 40 degrees F degrees C is equal to minus 40 degrees F. Right, so I'm going to say then, if we take this as C, and then I'm going to use that to find F. So F is going to be equal to 1.8 times by minus 40 plus 32, which is going to be equal to 1.8 times by minus 40. It's just like putting negative numbers in brackets. Plus 32 gives us minus 40. Right, which is what F we were told. There we go. Right, part B, the temperature is minus 15 degrees C. Nick says because the temperature is negative in Celsius, it must be negative in Fahrenheit. Is he correct? You must show your working. So he's not right because of the reason. So let's have a look. So this time C is minus 15, so let's see what happens here. No, it won't be. Right, so we're going to say that F is going to be equal to 1.8 times by minus 15 plus 32. So provided this multiplication is less than 32, it'll be a positive temperature. Positive temperature Fahrenheit. So times by minus 15 plus 32 is going to give us 5 degrees Fahrenheit. Is he correct? No. Okay, question 32. A linear sequence starts 11, 21, 31, 41. Writes out an expression for the nth term of this sequence. So this is going up in tens, so it would be 10n. And then what do we need to do to the number 10 to get to the number 11? We need to add on 1. So it's 10n plus 1. Okay, question 33. The pie chart shows information about the voters in an election, men and women. 3,360 more women voted than men. Work out the total number of voters. Okay, so the first thing I'm going to do is to work out this angle here. So I'm going to do 360 minus 110. So that's going to be 250 degrees. The next step I'm going to do is work out the difference in the angles. So I'm going to do 250 minus 110 is 140. So that's the difference. And the difference is equal to this value here. So if I do 3,360 divided by the difference, which was 140, that will tell me how much each angle, how many voters each angle is worth. So if I times it by 360, that will tell me the total number of men and women that voted. So 3,360 divided by 140 times by 360 gives us 8,640 voters. 8,640. Right, question 34. A is a common factor of 72 and 120. B is a common factor of 6 and 9. Work out the highest possible value of A and B. So A is a common factor and B is a common multiple. Right, so if we're trying to work out the highest possible value of A over B, we want the highest value that this could be, which would be the highest common factor of those two numbers, divided by the lowest possible value, so the lowest common multiple. So we want the highest common factor and the lowest common multiple of these two numbers. So the highest common factor is going to be, by inspection, it's going to be 12, I think. Easiest way to check that, though, is 72 over 120 as a fraction. Calculator does have a highest common factor, but I'm not a massive fan of it. 3 over 5, and what it's actually cancelled down by is the highest common factor. So if we do 24, yeah. So the highest common factor is 24. So we're looking at 24 divided by the highest common factor, lowest common multiple. So again, we can do a similar way for this. Your calculator can kind of do it. That will cancel down to 2 over 3. And then if you actually do the lowest common multiple of those two numbers, then is either 6 times by 3 or 9 times by 2. Both will work out, so that's going to be 18. So we're looking at 24 over 18. Again, 4 over 3. Question 25. The first two cube numbers are 1 and 8. Show that the third cube number can be written as the sum of three different prime numbers. So the third cube number, first of all, is going to be 27. And then we're looking for prime numbers. Right, so we want three prime numbers that add together to make 27. So the lowest prime number is going to be 2. However, if we think about this, that would leave us with 25, which is an odd number. And 2 is the only prime even number. So we can't add two numbers together and get an odd number. So it can't be 2. So let's take out the next smallest. So if we said it was 3, that would leave us with 24. And we can make 24. I think we can make it a few ways actually. It could be, let's say, 5 and 19. Could we do 7 and 17? That would also work. 8, 9, 10, 11 and 13 would also work. So I think any of those would be absolutely fine. So I'm going to go for the smallest though. 3, 5. I'm going to go 27, 3, 5, and 17. Right, question 26. Round 1 of voting for head student is taking place in a school. In each round, 2 of the students must receive at least 4/15 of the vote. What is the largest possible number of students that can reach round 2? So how many lots of 4/15 can we make? So if we think about it, if we do 15 divided by 4, that's going to be equal to 3 of 3/4. So the maximum would be 3. Part B, there are 900 votes in round 1. Mike receives 180 votes. Amy draws a pie chart to represent the results. Here is a method for working out the angle needed for Mike. 180 divided by 900 times by 100 equals 20, so the angle must be 20 degrees. Is Amy's method correct? No. Give a reason for your answer. So that would be a percentage, so that would be 20%. That wouldn't be the angle. So I'm actually going to say that would be the percentage. That would be the percentage. Not the angle. Then I'll do a second statement. She should have done. 180 divided by 900 times by 360, and we'll even put in what that should be. 180 divided by 900 times by 360, 72 degrees. Right, question 37. 93 people are asked if they played online games one day. The frequency tree shows information about their answers. 75% of people who answered yes played one game. Okay, complete the frequency tree diagram. So the first value I'm going to put in is this one here. That'll be 93 minus 48, which will give us 45. And then 75 said yes, so if we times that value by 0.75, so 48 times by 0.75 gives us 36 there. And then if instead of times by that, we times by 0.25, that'll give us our other value, 12 there. Right, one of the 93 people is chosen at random. The probability that they use social media is more than 0.68. What is the smallest number of people who used social media? Okay, so if we call the number that use social media, if we call it x for now, so x over 93 has to be greater than, more than 0.68. So x has got to be greater than 0.68 times by 93. So x has got to be greater than 0.68 times by 93. 0.68 times by 93 gives us 63.24. So it's got to be bigger than 63, so we're looking at 64. Right, question 38. Ben and Catty throw darts at a target. Ben's ratio of hits to misses is 5 to 1. Catty's ratio of hits to misses is 3 to 1. Ben says 5 is bigger than 3, so I must have got more hits than Catty. Give an example to show that this might not be true. So let's go for if Ben. Before I try, let's say Ben only throwed 6 darts. Let's say though that Catty threw 8. Then she would have hit 6 and missed twice. If Ben throws 6 darts, he hit 5 times. If Catty throws 8 darts, he hits 6 times. So has more hits. And that would be fine. Right, question 39. A, B, C, D, E is a pentagon, so a 5-sided shape. Work out the area of the pentagon. Okay, so we're going to treat it as 2 separate areas. We'll call it area 1 and area 2. So area 1 is a trapezium and area 2 would be a triangle. So the total area, so we'll go for the total area is going to be equal to area for a trapezium is a half. Don't need to write half twice. A half of 14 plus 20 times by the height, so times by 11. To that we need to add the area of a triangle, which is a half of, and that's our base times vertical height, a half of 10 times 7. And then our calculator can do this for us. So a half of 14 plus 20 times by 11. Check that I've typed everything right there. Instead of a half, I've gone for 0.5. 14 plus 20 times by 11, yep, plus 0.5 times by 10 times by 7. So that gives us a total area of 222. And we've got our unit, so it's just that straightforward. Right, question 40. A company sells houses. The line graph shows the number sold per week for 30 weeks. So number of houses, number of weeks. Work out the range of the number of houses sold per week. So the maximum number of houses sold is 5. The minimum one is 0, so that would just be 5. Work out the median number of houses sold per week. Right, for the median then, so if we're looking at 30 houses, 30 weeks, 30 plus 1 divided by 2 is 15.5. So we're looking where the 15th and where the 16th value would fall when in size order. Now the bar chart has them in size order. We're just going to keep a running total. So we've got 2 houses that are 0 or less. We've got 2 plus 4. We've got 6 houses. 6 houses that are 1 or less. We've got 6 plus 3 is 9 houses that are 2 or less. Plus 6, we've got 15 houses that are 3 or less. So our 15th value must be a 3. And our 16th value would be a 4. So we take the average of that, so our median would be 3.5. Right, part C. The company sells 3 houses. The prices are 185,000, 239,000 and 136,000. The company earns 2% commission on each house. In total, how much commission does the company earn on these 3 houses? So we want to add the 3 prices together. So 185,000 plus 239,000 plus 136,000. And then we want to work out 2% of that. So we would just times by 0.02. And that'll give us our commission. So 185,000 plus 239,000 plus 136,000, and then we want to times by 0.02. So we're looking at 11,200. Right, question 41. P and Q are points. The x-coordinate of Q is 4 more than the x-coordinate of P. The y-coordinate of Q is 5 less than the y-coordinate of P. Work out the gradient of the straight line through P and Q. Right, let's kind of put this in Q. It's 4 more than P. So if we call P x, y, and if we call Q, the x-coordinate of Q is 4 more than the x-coordinate of P. So we'll call that x plus 4. And then the y-coordinate of Q is 5 less than the y-coordinate of P. So that would be y minus 5. So the gradient is going to be equal to, I'm going to do it this way around. So the difference in the y-coordinates, which would be, and this is quite a nice, because the y's and the x's will cancel. So y minus 5 and minus y, and over the difference in the x-coordinates, which would be x plus 4 minus x, which is going to give us minus 5 over 4. So minus 5 over 4. Right, that brings us to the end of the paper. So before I sign it off, I will just bring up the topics and some rough grade boundaries. Okay, so all of those topics are roughly equate to the questions that you've just that I've just talked you through. So if you've particularly struggled on one of those topics, please do put a bit of extra time in revising that area before your exam. What I did was, like I said, I used the First Class Maths 5-star and 4-star to generate the topics. Then I've gone and used AQA's exam analysis to find the questions, and then I've arranged them. I'm just double checking. I've arranged them by national facility, so that means the goal behind that was to just have a paper that built in difficulty gradually, a bit like how it would when you sit the actual paper. but that gives you some very, very rough grade boundaries from students that sat it. Thank you very much for your time in watching the video. I hope you found it useful. If you've got the time, I would also recommend giving my good chance papers a try, just to maximize all of your revision. If you've got any questions, comments or feedback, please type them into the description, into the chat, and I'll get back to you fairly quickly. I'm fairly sharp with that. Other than that, thanks again, and good luck with the rest of your revision, and I will see you soon.